Good morning. Stuck in traffic with Wolf Gorlick. A couple minutes on information security. Today talking about the Apple Store, right? So you got the App Store, iOS apps go into it, iPhone apps load from it, iPad, what have you. Recently there was announced an attack. It wasn't necessarily an attack on the store itself, it was an attack on the apps in the store. And this is known as XCodeGhost. So today we'll look at how XCodeGhost works and how to prevent against it. Keeping in mind things that we've talked about in the past, such as threat modeling, balloon tower defense, where not all your controls are going to work, those types of things. Here is XCodeGhost. Developers download Xcode, which is your ID and your compiler for an iOS app. They download to OS X. Now, you download it from App Store or from Apple, no big deal. You download it from someone else, could be a problem. These other third-party sites had infected versions of this Xcode, and what it did was the code never changed. But when they compiled the code with this infected version, it would embed in a malicious payload. Not the first time this has happened. You guys may recall that way back when talking about open source apps, there was a proof of concept for GCC on Unix, right, to show that how well do you trust your code, only as well as you trust your compiler. So not the first time. So you compile your code, it's infected, you run it on your iOS emulator on your Mac OS X to make sure it's good. That code will dial back to a CNC, give some information. There's conflicting reports. Some of the reports said at that point in time, there's the ability to send commands back and execute attacks on local systems. But again, that's been conflicting. I haven't seen any confirmation of that. Then, at some point in time, the developers would publish these apps to the App Store. App Store looks at content. App Store looks at code. Turns out they're not necessarily looking very close at the compiled application. So this malware then finds its way into the App Store, and now you've got a bunch of infected apps all over the place. So how to prevent against this? One, user training, of course. Only download from known good sites, only, watch your compiler, blah, 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 blah. Good luck with that. But that's a good one. First tower, percentage of success there. Number two, for developers, and especially for OS X, right? All these orgs are running Macs now. Very few orgs are doing any security controls around them. It's kind of strange that most of the security management tools have gotten pretty mature for Windows, not so much for Macs. So things like file security monitoring, or file integrity monitoring rather, on your Xcode environment, on your development environment, right? Lock it down, prevent developers from accidentally changing those files. That's a good idea. When that malware executes and calls back to the CNC, you've got a couple points there. You've got a point on the firewall if you're doing sort of application proxy to catch that traffic. You've got a point on DNS, right? So if you're using something like OpenDNS, you could see those lookups and be able to respond at the point of the malware being infected. What about publishing to the App Store? Right? So one of the things I think is interesting about this is if you have a mature SDLC program, if you're following something like SAM, and you've got a separate build environment, the developers could get infected, but that build environment would be separate and maintained pristine. So by having a segregation between those who write the code and test it and those who do the QA and publish it, you have protection against something like XCodeGhost. Bam, that's how you do it, right? Good SDLC, good network controls, good perimeter controls, good controls around DNS, and good controls around your endpoint, right? These are all basics. Every one of them can be bypassed. We're talking balloon tower defense all over again. But that's, when you look at something like Xcode, that's how Xcode gets in, by chinks in each one of those steps. And next thing you know, everyone's downloading malicious code off of Apple. So enjoy your iPhones and have a good day.